Evolving genetic algorithm solves polybridge puzzles. Interesting.
Polybridge 3 was released recently. Okay, well, I might be a bit late to this one, but still, it's a relevant topic on YouTube, and it's also pretty fun. But there's a problem. I'm way too busy to be playing this right now. And instead of solving all of these
Okay.
puzzles, I could create a program that could solve it for me. Specifically, a program using a genetic algorithm, an AI if you will, which can solve all of these puzzles automatically for me
Okay.
and try and get the lowest cost possible. To start off, I will need to replicate the entire Polybridge game. Okay, maybe not everything, but just the
What a start. I'm too busy to play this game, but first let me replicate the whole game.
most important part, the bridge
Nice.
building and simulation. To do this, I used my game engine of choice, Unity. This is actually what Polybridge is made in, so it also gives an extra touch of authenticity, but I guarantee this won't be anywhere near as polished. Bridge building in the
Okay.
game has two distinct steps. The paused mode, where the simulation is not running and you can freely place points and connect roads or supports. Then the
Okay, I'm
simulation
following.
mode, where you can no longer place anything and the bridge is simulated,
The
usually
fun
with cars
part.
driving across its surface. Let's start with the first one. I created a point prefab and a road prefab, and made it so that when you press the left mouse button, a road starts being made and connects to another point at the end of your cursor. I also want the shape to be predictable, so I snap the points to the nearest whole number. I also use this bit of code here in order to make the road piece rotate towards the point and to scale it to the correct size. After that, I created the simulation aspect, which automatically generates hinge joint 2D components on each of the pieces, with the anchor and connected body automatically configured. Now, when I click play, the bridge is simulated. The script generates
That looks exactly like it. But how does he know the values of, like, I don't know, don't you need, like, the values of gravity and whatnot? Is it really this easy? Wow, I am absolutely shocked.
the required components, and Unity's physics system handles the rest. We also don't want
Oh,
road pieces to
it's
collide
an inbuilt physics system. Now that makes a lot of sense.
with each other, only other things, and luckily Unity has this awesome setting in the project settings to turn off collision between specific objects, so I turned off self-collision. Now one problem we have is that this bridge is indestructible. Clearly it was made by engineers, so in order to fix this, we just need some architects. So this is the game, but now we want the actually interesting part of this. I began implementing the genetic algorithm. If you don't already know, let me explain
What's a
how it
genetic
works.
algorithm?
In a genetic algorithm, there's a population of agents. In each generation, these agents are tested and the performance is scored using a fitness function. After they are all scored, some of the best ones are chosen to
Nah, I know this one.
reproduce and create offspring for the next generation. Their genes, which are just a list of numbers, are combined between the two parents using different crossover methods. There's also a small chance for a genetic mutation. Through this relatively simple process, it is possible to train an agent to solve many different types of problems.
The genetic mutation is there, so if there's a dead end, that the genetic mutation sooner or later theoretically will overcome the dead end in some way.
Before I can start making this work with the genetic algorithm, we first need to have a way to programmatically place points and create bridge pieces from coordinates. So I created this function, which allows me to input 2 points in the form of Unity's
Yo, I'm not gonna lie, this video is way too smart for me. I consider computers to run on wizardry and black magic, mostly black magic. Honestly, it's like a 70-30 split in my mind, but black magic nonetheless. So yeah, I'm not sure if I don't understand anything written here. I ain't gonna lie. I'm the guy who asks for my printer to be fixed. Well, my printer's working completely fine. It's just the fact that IT otherwise doesn't have anything to do, in my opinion.
vector 2s, and it will create a bridge piece. I then created this test function, which just builds a predefined bridge, and there we go, easy integration. Now for the fun part. Each agent in the population will have its own script, which will handle everything from calculating its fitness to spawning in the bridge pieces according to its
Makes
genome.
sense.
Inside the script, I created an initialization function, along with an elapse function. The initialization
I don't even know what an initialization function means. I'm a idiot. Idiot explanations, please.
function will run when the entity is spawned in by the population manager, and copy all of the required data, as well as perform initial calculations, and build the bridge using the function we created earlier.
Of
The elapse
course.
function is used to perform calculations during the simulation phase, such as calculating the fitness, checking if any failure parameters have happened, such as any pieces
Makes
breaking,
sense.
or accelerating the car's rigid body. This function is similar to what the update function in Unity is used for, except instead of being run continuously as fast as possible, it is run at a deterministic speed at the same time as all of the other agents. This is
Well, at least I understand deterministic speed.
especially important for things involving physics simulations like this.
Yeah,
Now
because that's a physics term.
It is time to make that population manager, which will keep track of the 100 or so agents, and perform all of the genetic algorithms required to make them improve. We first instantiate all of the agents, along with a genome script to go along with it. I didn't actually make a genome script, and just reused my very old neural network class, because I'm lazy. Then, in the fixed update loop, all of the agents' elapse functions are called at the same time, and the population manager keeps track of how many have had a failure state. Once this loop is completed a couple of hundred times, or more or less depending on how long you want it to be simulated, then all of the agents are stopped. They are then sorted, and the one with the best fitness has its genome saved to a file, just so you can continue from where you
Makes
left
sense.
off training it, or replay it later. Then finally, the genetic algorithm. The method used in this project is called tournament selection. A random number of agents are picked from the population, between 2 and 4 for this, and the one with the best fitness out of all of them is chosen to be a parent. This process is then repeated, finding a different group of agents, and then the highest becomes the second parent. Now that we have created the genetic selection process, how are these genomes actually being used to create the bridge? Since I'm using
By the way, if you like this and are for this, you dirty eugenics supporters, so am I. Any. I don't even know how many people understand that joke.
my previously existing neural network system, I decided to generate bridges like this. I iterate the first array of genomes and use the values as XY coordinate pairs. I start from the anchor on the left, and each coordinate dictates where the next point will go, with a bridge piece connecting the last and current point.
Huh.
It also does some checks, such as making sure the length of the pieces does not exceed 2 units, and adding up the costs and other pre-physics simulation fitness calculations. Speaking
Okay.
of, how do I calculate the fitness for a bridge? It would be nice if the system could just look at an agent's output and say, yes, that looks very bridge-like. But it
I have a question because how do you calculate the fitness? The fitness is how good the bridge is, by the way. Because can we actually rate a total bridge? Because I'm not sure. We actually should probably rate it at least on parts. Like, this bridge was perfect until this part right here, for example, and then it became bad. So, half of the bridge is like really, really solid. Plus, we also need to make it as least expensive as possible.
is more difficult than that to algorithmically tell how good a bridge is. In order to get the fitness calculation just right, I actually created multiple different methods and factors which are summed for the final value. First, of course, there's the simulation. In this, the distance from the car, which in this case is actually just a ball for simplicity's sake, is measured and scaled between 0 and 1. Next, I have one that counts the total number of anchors that the agent has not yet connected to, and adds the total distance from the nearest point. This is to encourage connecting to all of the anchors, since they will provide structural stability, and of course, a better bridge. After this, I have a
That's already a flaw, actually. That is already a flaw. So whatever we come out here is not gonna be perfect just by the rigidness of the limitations of the creator, which is interesting. And this is by the way, I have seen similar videos. One of the more interesting videos I saw on this was a wind turbine, if I'm not mistaken, was called, or some kind of thing that catches wind, and it was a funky looking thing. And one of the things I noticed from there was that you have the genetic mutation, so it stops dead ends. But at a certain point, something interesting may happen. The simulation can maybe create something that is good enough and is the current best iteration from everything it has noticed, but it hasn't actually tried everything. And the genetic mutation is not going to allow it to actually revert and go in the right direction because the mutation is not big enough to actually make an impact, and the mutation just gets squashed in the next upgrade of the breeding process, which is crazy.
time reward. where the agent is given a better fitness the longer it is alive. It is considered not alive if it has any failure condition, such as pieces breaking. Finally, there's a fitness modifier that rewards lower cost bridges, which is calculated by adding the cost of each bridge component multiplied by its length and averaging it. To finish this up, I added booleans, so you could manually change if these factors affect the fitness from inside the editor. And now we have just one last part. I need to make sure that the simulation plays as closely to Polybridge as possible. So I booted the game into sandbox mode and looked around to see where the specs of the materials and vehicles were. Luckily, after hovering over the vehicle, it tells me that the mass is 3 polygrams, which I assume can directly translate into Unity's physics mass. So I set that for the roads and beams. I can also hover over in the menu and view their cost per unit, as well as their mass. Unfortunately for these, the value did not perform like Polybridge inside my Unity simulation. This may have been due to the fact that I use hinge joints, whereas I don't really know what Polybridge used, and also many other factors. So I decided to manually tweak the values through experimentation. I set up equivalent stress tests for the roads and wood pieces in both the game and my simulation, changing the values until they performed as closely to the game as possible. Now it's finally time to test. I activated these fitness modifiers and began the simulation.
This is how it starts.
Well, maybe they'll get there eventually.
This is how it starts. It's pretty good process.
After some minor bug fixes, like incorrectly accessing places from an array, subtracting this when I shouldn't, not adding 2 at a time over here, and more, let's actually do this.
Ooh. Fitness generation. I don't even know how this actually works. What does it mean? Generation 7.0? Oh, it's the average fitness. Okay, interesting. Look at that, it's getting there. Ah, the music is killing me. Look at that. It's kind of stuck. Oh, that's the genetic mutation. I'm looking at the fitness right there. Oh, wait, it's finishing it? Or almost finishing it? No, it is finishing it. Okay, that's a pretty wonky, funky thing to actually do. Very interesting. Huh. Oh, got over.
Definitely is not a bridge I would be willing to drive over, and it has some unique qualities about it. But I'd say it definitely completes the task. Some of the original bridge designs were even more interesting, as they were very dynamic and more swing-like. I think that the biggest issue with using genetic algorithms to solve problems is that they always, and I mean always, find a way to cheat the game. See this example here. The fitness for this agent is calculated by the distance from the ball to the flag. But what would happen if the ball were to fall into this abyss here? Well, the agent would get a bad score. So what does the algorithm do? It keeps the ball from falling into the pit, and therefore it gets a better fitness. It isn't giving the solution we wanted, but it is still...
Yeah, this is what I said at the start. Okay, interesting video. This is what I said at the start. The genetic mutation is not big enough to actually stop this problem, most likely ever.
Performing well, because our reward function was not specific enough, which is actually a big problem with reinforcement learning in AI.
Yeah,
well, that's sense. The video. Hit the like button if you enjoyed. If you did not, please hit the...
Was pretty interesting. I never even imagined someone would attempt something like this. Kind of cool. Kind of liked it. You know, a little bit too more techno-wizard mumbo-jumbo. Didn't understand anything of that. But hey, it's always fun to look at this part. Caveman brain, what can I say? Anyway, this was Quizzer Sid said. Thanks for watching. Subscribe if you haven't already. Have a nice day. Bye bye.